All right. So, part 2, here we go. 6.3 second waves. Yes, George, there are in fact 2 waves of the Industrial Revolution. All right. So, here we go. All right. So, we have new technologies. And the thing that changes the game, electricity. I don't know why I did not underline that or highlight that, but whatever. You can thank this American guy. What? AP Euro talking about Americans? Crazy. So Samuel Morse, American. Once again, AP Euro, all about names, what they did. So Samuel Morse, what did he do? The telegraph. What's the telegraph, you might ask? It communicates over long distances, woo, by transmitting coded signals via wires. All right. And the key part of this was using long and short symbols, letters, numbers, and all that, like the do-do-do-do-do. That's Morse code. Wow, named after him, Samuel Morse. So he, huge invention. All right. Next, how can we connect that to America or to Europe? How can Samuel Morse and his telegraph get to Europe? Well, you just put it in the water. And that's pretty much it. So in the 1870s, they put a telegraph wire in the Atlantic Ocean. And voila, you link the economies. And that was the big effect, right? Now we can communicate to each other, talk about money, politics, all the things. Now, knock, knock, knock. Who is it? It's George. Man, look at him. He's shooketh. Who's knocking at the door? Chemical engineering. Ah! All right. So, chemical engineering is coming about, and you can thank George. He's a British dude. He laid the foundation, the foundation for chemical engineering, and he wrote a book called A Handbook of Chemical Engineering. Wow, very creative, George. You know, math and science people, not the best at creativity, but alas. So he wrote this book, A Handbook of Chemical Engineering, and it was the first textbook of its time to say, hey, chemical engineering is like a thing, and we really need to study this. Okay, so George E. Davis, he wrote this book, handbook. It was a textbook, right, about all the chemical engineering things. What chemical engineering things, you might ask? Oh, you know, how to properly train people, right? So in George E. Davis, really his whole point of existence is to make things improve, right? That's the name of the game, Industrial Revolution, is improving and making it more efficient. So he's helping engineers make things more efficiently by using chemical processes. He's using certain designs and optimization methods. He's a big, I don't know if in science class you worked on like filtration and titration, I think he's a big component of that. But for this class, you don't need to know all that. You just need to know that George E. Davis, E for chemical engineering, helps improve things, right? He's improving engineers with how to make things more efficient. He's improving optimizations. He's making things more efficient, which leads to more profit. And that's the name of the game, right? More profit, more money. Now, a big breakthrough was not through George E. Davis. It was through a guy named Goodyear. Like you might have heard of Goodyear tires. Yep, you can think of this guy with these crazy sideburns. And he's like, oh, look at this, rubber. All right, that rubber process is called vulcanization. All right, and it's essentially a process to make rubber hard, then to make it more durable so it can be outside and in different types of weather conditions and such. So the wires inside can be protected. All right, and this really was important because it was a coating for electrical wires. Without this, electrical wires were very, what's the word? Like vulnerable. They're very sensitive. And so this little rubber coating kind of protects the wires, which is very important. Okay, next. Now we're moving to transportation time. You see in the first industrial revolution that railroads do start coming about. However, they're mostly steam engines. Okay, notice the steam, the water, right? Water, steam, water, steam. But now in the second wave, railroads are dominating. They're becoming the sensation, the bee's knees, as you might say. Now, if you don't remember anything out of these notes and slides or whatever, just understand: first revolution, water, steam. Second, not water. All right. So the first one, all steam, all water. You see a lot of stations near oceans and rivers and canals because you need water for the train to move. But now, with the second industrialization, with the help of, wow, I'm already blanking. Wow, why am I blanking? With the help of, what is that guy's name? See, this is what happens when you're up. Whew. Man, that was a brain fart. All right, with the help of the Krupp family, right, with new the steel, improving the Bessemer process with steel, putting in railroads, we have thousands of new tracks all across Great Britain, all across Europe. All right, which means we're linking distances apart, which means now it's easier for people to move, not just back and forth from city to city or from rural to rural town, but now you can have people moving from country to country, which is crazy. Wow, this is blurry. This was not blurry when I first found this, but you can see these are all the main train station hubs, right? And this is 1851, primarily near the tail end of the first industrial revolution. And now we have the second industrial revolution, and look at all these different lines. These represent railroad lines. Hopefully you can kind of see that there is a difference. Cool. Moving on. The ICE kicks the butt of the steam engine. The ICE stands for internal combustion engine, and it is the driving force for ships, trains, automobiles, planes, all those things. All right. This guy effectively kicks the steam engine out because this guy, the ICE, is way more efficient and it's faster than the steam engine process. Okay. So, it was more versatile, okay, and it helped improve lots of different sectors. It helped the mining sector, agriculture sector, manufacturing sector, mainly because it is faster and more efficient. That's the common theme that you're going to see: efficiency and efficiency. Efficiency, efficiency. Cool. Next, now with transportation, with the effect of the ICE, I mentioned gasoline? Yes. No, it's not even highlighted. Okay. Well, the ICE uses gasoline. Okay. And so this gasoline leads to the transformation of transportation. Say that 5 times fast. You look at this guy. That's a Mercedes-Benz. You kidding me? I could make that in my garage. Well, that's the Benz automobile. Everyone likes to think this guy did it first. No. This crazy German, Carl Benz, he did it first. However, Henry Ford learned of the assembly line of mass production in Michigan, all made possible because of the internal combustion engine. And as a result, it led to people using streetcars, right? These are streetcars. Now, streetcars are more popularized in America, or in the North America, but they still use streetcars in Europe. However, regardless, the ICE allowed dramatic reduction in transportation costs, right? Now, think of it as like within there's so many different modes of transportation. So now with so many different options, the prices are low because people can choose various levels of transportation. And as a result, we have leisure travel. So now because we have new tracks that are laid, thanks to the ICE, because now they're putting ICEs in trains. Now we have people going from country to country, city to city, town to town, which leads to leisure travel. So now we have people going on holidays. Okay. Now we see a big birth in advertising. All right. Due to lots of consumer goods being available at the market and low prices. With those two combined, we start to see a need for companies saying, how can we get people to buy our products? And that is called advertising. So we need to advertise this so more people can buy our products so we can make more of it and make more money. All right? That's essentially what advertising is. If you didn't know, and if you did, well, there you go. All right, now near the end of the 19th, so late 1800s, industrialization led to a mass influx of demand for goods. And so now we see consumerism reborn. All right. I think consumerism started during the cottage industry and the putting out system, but then it kind of petered out. And now we see a huge spike in consumerism during the second wave of industrialization. Alrighty. And where can people buy things? Well, they need to go somewhere. They can't just buy it at a market. So let's just put them all together in a department store. The first department store was built in France. However, they did spread throughout Europe and in North America as well, primarily in New York City and Boston, as well as London and Paris and major European cities. That's where they first began, and then they slowly petered out into other major cities. What is a department store? It's essentially a giant mall, right? Massive stores within a giant building that have everything that consumers might want/need. There's clothes, furniture, toys, anything, food. And as a result, due to advertising in the late 19th century, we have consumers literally staying hours at these department stores. All right? Because now we have transportation is easier, you can come and go, and it's just a free-for-all. Once again, this is entering into leisure activity. Once again, your poor workers, unskilled workers, are not enjoying these department stores and transportation methods. This is mainly your middle class, upper class folk. Alrighty, and that is it. Okay, I will get to the more political side tomorrow, but this is the first wave. Okay, so think clothes, steam, coal, all those guys you learned in middle school and U.S. history class. Unskilled workers, manual labor, cities are building, and now we enter a second wave where we see steel and electricity and chemicals and cars. The technologies we see, the ICE, the Bessemer process, assembly line, telegraph. The energy source is now electricity. We are getting rid of steam. And now we're using gas, right? We're using gasoline-powered vehicles and transportation. We are mass producing things. We need semi-skilled workers and major infrastructure, and now we see huge consumer culture and mass consumer goods. Alrighty, I will see you guys tomorrow.